Hey guys, it's Doug here with your Week 7 MyStats Lab Problem 9 example. And in our problem, we have a magazine looked at the success of CEOs with MBAs. And of this 1,078 CEOs that responded, 30% said they had earned an MBA. So we're going to estimate the percentage of all CEOs who have earned MBAs using a 95% confidence interval. So what do we know? We know 1,078 responded. And we also know that our portion of success here, or 30%, say they have earned an MBA. So let's look at our assumptions and conditions and see where we stand there. The independence assumption. Well, whether or not one CEO has an MBA has nothing to do with another one, whether another one has earned it or not. So we can say that they are independent. Second is our randomization condition. Now we know that 1,078 answered the survey, but we cannot be certain that this is a non-biased response. We're not really sure how the 1,078 responses, where they came from, or how they got there, whether they were biased by whether they had an MBA or not. So we cannot say that it is random. Next is the 10% condition. Here again, 1,078 responded, and sitting where we are, we can't really say whether that's more or less than 10% of all the population of CEOs. So I cannot honestly say that we can meet that assumption either. So we'll move on to our fourth assumption condition, and that is the success-failure condition, where we must have both successes and failures greater than 10. Looks like we do, but we'll check it anyway. We know that our success rate, our p-hat, is 0.3, which makes our failure, or our q-hat, 1 minus p-hat, or 0.7. And we have 1,078 respondents. So let's just go ahead and check that. We'll do a quick formula here. So our success will be equal p-hat times n. Let's try that again. Equals p-hat times n. Enter. That looks a little better, doesn't it? And also our n times q, so equals q-hat times n. There we have it. So both of those are way more than 10. So we know that the success-failure condition is met. So we met 2 of the 4. That's it. So let's go ahead and construct our 95% confidence interval. And for this, we need to know our margin of error. And to find that, we need to know our critical Z and also the standard error of p-hat. So we'll first look at our critical Z. Here's a chart here that I know you're very familiar with. It's been in other problems. So I went ahead and copied and pasted it here. We know our alpha is 0.05 because our confidence level is 95%. This is going to be a two-sided because we're looking at 30%. It can be more or less. So we know that our critical Z here is going to be 1.96. Now we can go ahead and find our standard error. And the standard error is the square root of p-hat times q-hat over n. You've done this a bunch of times also. So let's go ahead and look at that here. And we'll say equals, and I'll start typing the word square root, and it comes right up there for us. I'm going to use 2 sets of parentheses as I always do. So I'm going to say p-hat times q-hat, close those parentheses, divided by n, enter, and there we have our standard error at 0.014. Now that we have our critical Z and our standard error, we can calculate our margin of error. So I'm going to go here, and we'll again let Excel do it for us. Equals our critical Z times our standard error, enter, and there we have our margin of error at 0.27. Now let's go ahead and calculate our confidence interval here, which is going to be p hat plus or minus our margin of error. So we can start with a p hat minus the margin of error for our lower part of our interval. So we can just say equals p hat minus our margin of error. To get our lower, for our upper, we will say equals p hat plus our margin of error. And there we have it. So our confidence interval will be from 0.273 to 0.327. So moving along, part B asks us, some believe that fewer contemporary CEOs are earning MBAs. Suppose we wish to conduct a hypothesis test to see if the fraction has fallen below the 34% mark. What does the confidence interval indicate? Well, what do you think? Where is 34%? It is not within our 95% confidence interval. So, being that it lies outside of that, you know what we think about that. The confidence interval does not indicate that that is within the range, so the 34% doesn't work for 95% confidence interval. And then our last part, part C. What is the level of significance for this test? Well, this test has us looking below 34%. So that means that we're going to have a upper or lower tail test. So what do you think about that? Well, if we have both ends a two-tailed, one end a one tail, it could be upper or lower. This test is an upper tail test because we're looking for everything below 34%. So that leaves us with a little bit of range on the upper side. Since this was a 95% confidence interval, then alpha in this case would be 0.025, half of the 0.05, because half is on the upper, half is on the lower. So the level of significance of this test is an alpha of 0.025. Well, there you have it. That's all we have today. That's your Week 7 MyStats Lab Problem 9 example. We'll see you again.